Yeah. Hey, wait. 15. Okay, like today we are going to learn quantum physics. Okay, what do you think of quantum physics? Hi, hi, Marcus. I see you, Marcus. You're off camera. Also, can you want to accompany? Also, can. Marcus. Okay, so quantum physics. Apa itu? Okay, so actually before quantum physics, we call them all as classic physics. Okay, I make the story shorter. Actually, if the story quite long, but no choice, we need to make it fast. So classical physics, or classical physics is all about force. So force will make motion and also the change of the energy. Okay, so and we also call it as a macro physics. So that means outside of the molecule, a little bit touching to the simple molecule. But when it comes to quantum physics, actually we still talk about the force motion energy. Okay, but now actually we are still talking about them. But now we talk about microphysics. Okay. Okay, then when they study microphysics, they find out, oh, why all of the macrophysics not apply if they use F equals to ma. If they use linear speed like V equals to U plus AT, if they use energy, got kinetic energy, got gravitational potential energy, got elastic potential energy, and they find out, why cannot? Why not applicable? The data from the experiment and the data from formula totally different. So here comes to the new world, quantum physics. Okay, so and then they found out this is an atom. Inside an atom got proton and neutron and electron. But they still find out inside the proton got quark. Okay, it's something smaller than proton. Okay. Okay. And also they use the cat to simulate, to imagine an experiment called Schrodinger cat. Yeah, cute, huh? Hi, so cute. Okay. Okay, so we also learn the cat, Schrodinger cat. So the cat also want learn physics. Think so. She pretends she learn physics. I will feed her with something else. And snack. Okay, so now comes to the quantum physics. Apa ini quantum theory of light, quantum energy, properties of wave particles, duality. Okay. And then photoelectric effect. Jaden. Photoelectric effect is a key. Is very important. All of the calculation or in photoelectric effect. Okay. Theory quite easy lah, but all of the calculation in photoelectric effect. Apa itu photoelectric effect? Okay, anyone can tell me what's the meaning of photo? Let's take a photo. Photo means yes, very good. Yeah, it's a light. Okay, so when you shine the light on a metal surface, then electron will be emitted out. When electron starts to flow, emitted out means it will start to flow. When electron starts to flow, actually what will be flows on the same time? Current. Okay. So photoelectric effect means the light shines on the surface will give out, the metal surface will give out electron. Okay, we will study this. This is the most important part, most important theory or calculation, right? Not hard. We just touch the very surface of the quantum physics. Just very introduction, very surface introduction. Okay, so now quantum theory of light. So before we start, yeah, you need to recall back the EM wave. Still remember what is EM wave? Electromagnetic spectrum. So actually I teach Santalia, Matahari, and Yulik. I asked them to memorize a sentence. Like that easy to remember. Okay. So actually it's RMIV love you X. Okay. Yay, thank you, Ida. Okay, so how to remember? So what is the meaning of this sentence? RM means Ringgit Malaysia lah. I love you because X gamma coming for V actually means visible light because Roy giving birth. Okay, because Roy gave birth. So we need money. Okay. Okay, apa itu? So remember lah, RM I love you V X gamma because Roy giving birth. So and must remember, okay, R stand for radio, M stand for microwave. All of them are EM wave, so all of them have same speed, which is light speed. C equals to 3 times 10 powers of 8 meters per second. All of them. Alright, so I means infrared. Infrared. It is a must to memorize. If you don't remember the spectrum, you cannot do. No, you cannot do. It's hard for you determine the color and the wavelength. Okay, so V means visible light. So U means ultraviolet. X means X-ray. What gamma means gamma ray, right? So visible light, we normally say rainbow color lah. So in Chinese, normally primary school already learn 7 color lah. 红橙黄绿蓝靛紫 okay, 7 color. In English, you can remember in this way lah. Roy give birth. So Roy means red, orange, yellow, green, blue. You all normally don't see that called indigo. Indigo, V means violet. Okay, apa itu indigo? Looks like between blue and purple, indigo. Okay, 电子. Okay, then what else you must remember? See, the spectrum and the colors start with R. So remember in this way, R means really long wavelength. Listen. Really long wavelength. So means R for radio wave, R for red color. These two has the longest wavelength. But remember, V equals to F lambda. Last year, chapter 5 wave. So since now EM wave, the speed is C. C equals to F lambda. Means when your lambda increases, means on the same time, your frequency must be decreases. So lambda longest means at the left-hand side, frequency is the lowest. Okay. No matter color of wave lah. It's a must, it's a must to memorize. If not, when they change wave, you don't know how to differentiate them. Okay. Then now this one. That's why at the other end, right, your right hand side, the lambda is the shortest. Means what? Means it has highest frequency on both sides. You jot down already? Okay, RMIVUX gamma. Roy give birth. Left hand side, longest wavelength, lowest frequency. Right hand side, highest frequency, shortest wavelength. Okay, clear? Okay, that's why, what is infra? The meaning of infra actually means less than red. What is less? Wavelength is infrared means this ray have wavelength less than red. Infra means less than. Ultra means more than. So ultraviolet means this ray has the frequency more than the violet ray. Okay, so RMIVUX gamma because Roy gave birth need money RM. So now done. So now this is a part of electromagnetic spectrum. For this chapter, we just learn the spectrum here. Visible light. Okay, but you can see that this spectrum is different from my left, right, opposite now. So this is infrared, means here is red. So Roy, wait, it's okay. Push. Okay, so Roy give birth. The ballet lah. Okay. So if you can remember the sequence, no matter that the ballet or up down, it doesn't matter. So since here is infrared, here is red, here is violet, here is ultraviolet. I think this is ultraviolet. So this P will be exo, Q would be microwave. Okay, so now and then electromagnetic spectrum. Within last year, we learned that EM wave spectrum. We thought that the spectrum is continuously. Okay, normally it's continuous, but when scientists they try to do an experiment, they shine the light on the metal, and the metal gives out the light in a line spectrum. By the way, this is called continuous spectrum. But this one give a line here. How is line spectrum looks like? Okay, light spectrum for any material got their own specific line spectrum. So you can see lah. They shines the light for Hg is mercury, Ca calcium, H is hydrogen, and A sodium. And then they give out the line spectrum like this. Now, for mercury, as long as mercury, if you are not sure what is it, you just use line spectrum check. You'll find out mercury like this, got 2 violet, 1 indigo, 2 blue, 1 green, 2 yellow, 2 orange, 1 red. Okay. Then if you are not sure, they give out the line like this. Sure, this is mercury. And sodium give out the line spectrum like that. Okay, so this is how we use the line spectrum to determine the name of the material. Okay, so what's the benefit we use line spectrum to check? Okay, especially for okay, let's say a murder happened, then the police need to find the proof, anything lah. Let's say they found something X, substance X. How do they know what is it? So first is you use line spectrum. So you just shine the light and it gives which spectrum, then you will get the proof. And But another one for chemistry also can. For chemistry, we need to cut off some part. Then we put in a few samples. We test with some chemical solution or reagent. Also can chemistry way. But chemistry way need to cut long, need to spoil a bit the material. So a light spectrum is better because you no need spoil the material. Okay, but depends that still depends. Alright, so now when we say wave P actually would be the I think here is violet lah. Then here is red lah. I think they write wrongly. So here is violet, here is ultraviolet. Here is red means here is infrared lah. P is alpha. Ultraviolet, Q is infrared. Okay, frequency of P is, what do you think? Lower or higher than Q? According to the spectrum here. Like, everyone please answer. Thank you, Bethany. According to the spectrum just now I told you, which one has higher frequency? Hey, only Bethany, the rest leh. Thank you, Aiden. Thank you, Ichen. Thank you, Savindra. Thank you, Savinesh. Thank you, Grace. Thank you, Stella. Thank you, Dylan. Thank you, Deshaun, Kevin, Eric. Wow, I wish. Thank you, Shojan. Thank you, Marcus. I find out, oh no, I explained so much, then you still confused. Okay, P is ultraviolet. Thank you, Natasha. Q is infrared. Let's look back to the spectrum I explained to you. Really, really low. Okay, so F is actually inversely proportional to lambda. So the left-hand side really, really long means low frequency. So high frequency one would be the ultraviolet. Okay, high frequency. But here, take the ballet, the spectrum. I like to memorize spectrum from left to right. But this one, they start from right to left. No matter how UV will have higher frequency than Q, than infrared. But it's okay. We check now. That's why I always like to ask questions to check your understanding. Then from there, I get your feedback lah. Then you also can check your understanding now rather you found out when you were in exam. Okay, so now higher. So UV has higher frequency than infrared. Okay, so now all objects will emit magnetic radiation. Cold object also emits wave with low frequency. Hot object emits with high frequency. Okay, so how is it looks like? If you check your textbook, you can see, oh wow, 直加 I surprise. Okay, sorry. It's, maybe I use textbook. Textbook give you the colored background. Emits means they release out the light. Okay, emits means they release out the light like this. When you see the thermographic image of the car, you can see that this one is high frequency, this one is low frequency. Oven heating element also give out light, emits out the light. This one thermal radiation is light at different temperature. Okay, and so we get a graph of radiation intensity against wavelength. Okay, then here we comes to something new to you called black body. So what is black body? Black body doesn't mean it's black. It's just an idealized body. 就是一个很完美的一个物体。Okay, will absorb all the EM wave falls on it and then emits form of continuous spectrum or emits electromagnetic radiation by the temperature. Maybe. Okay, so this is so actually our ear also can say is a black body. So we say when the light enters the ear, undergoes repeated reflection on the inner walls, and then on the same time, it will reflect until it absorb all of the light. So we can say ear cavity is a black body. Okay, so now as the temperature of an body rises, an object acts as a black body radiator and emits thermal radiation of all wavelengths. So graph below shows the radiation intensity against wavelength of three types of black body at different temperature. Usually, every curve graph is narrower on its left, which is the area will be short wavelength and high frequency. So with increasing temperature, the wavelength approaching maximum radiation intensity. Radiation means it emits out the heat or the light. So normally, UV light will give the highest radiation intensity. Apa itu intensity? Anyone can tell? For example, light intensity. When we say something has high intensity, we say the body is, something is brighter. Okay? When we say something has low intensity, we say something is dimmer. Okay? So radiation means the heat and or the light can be emitted out. Heat and light can be emitted out. Okay, so we say high intensity brighter, low intensity dimmer. Get the idea? Okay, so when we say the higher the intensity of a black body means it absorbs more light or heat, then the more light energy it will emit. So the more light and heat energy it will release out. Emit means release. Okay, so you can see this is the K. K means Kelvin. Okay, so normally 30 degrees Celsius we already feel so the 30 degrees Celsius is around It's around 303K already. Teacher, is that why blue star are hotter? Yeah, blue star. So you learn in form 2. Yeah, form 2. So blue stars is the hottest. White stars, like our sun, okay, medium, and the red stars has the lowest temperature. Even though we say higher or lower, still higher than the normal heat, normal hot we consider. Okay. Okay, so now comes to the ideas of quantum physics. Okay, so a black body is an idealized body. When we say idealized body, means it will not exist in our real life, right? So it's 100% can absorb what? Absorb all EM radiation that falls on it. Absorb all EM means electromagnetic radiation. So radiation means come out from a body, like from the sun, and okay, say from the sun. EM wave, all EM wave that falls on it. And what is EM wave? This spectrum, all of this called EM radiation. Radio wave, microwave, infrared, visible light, ultraviolet, X gamma, red light, orange light, yellow light, green light, blue light, indigo, violet light, called EM radiation. So when I'm talking about EM radiation, I'm talking about all of this, right? Okay, so page 197, your homework, I just copy from the textbook, no, sorry, the answer. Okay, so it's the explanation from the textbook actually. All right, so now comes to the idea. Wow, okay, half an hour already. Okay, this one you all also do it yourself in page 198. I'll explain, but you fill in the blank, right? I explain and fill in the blank. Okay, here, classical theory, okay, about quantum. So actually, this quantum concept, oh my God, I forgot to send link to. Okay, this physics concept, sorry, this quantum concept actually can be defined or is discovered by our father of physics, Isaac Newton. Yeah, I can't believe it. From 1643 in 17th century. At that time, it's England. Okay, so you can see actually this is the summary. Summary. So at that time, they don't use the word quantum yet. Quantum is introduced by Max Planck. Okay, so, but he tell what? He say particles, nature of light. Okay, so okay, in classical physics, we think that light is a wave. That's why in Form 4, Chapter 5, we say light is a wave. We say light waves. That's correct. Okay. But sometimes the light also acts like a particles. Particles. So if we say light is a wave and then light is an energy, we say it don't have mass, no mass. But Newton at that time already said light can act like particles. Particles means could be an atom, could be a molecule, could be an ion, means it got mass. Light got mass. What? So when I first listened to this, I also feel shock. But I thought we learned light don't have mass since very young. Okay? But he said, no, actually the light got mass like particles. Yeah, so that's the, so we say quantum physics is most of the time opposite to classical physics. Okay, so classical physics means in macro world, means something not so directly talking about atom or molecule or particles. But quantum, yes, talk about particles. And all of the rules from classical physics not suitable to use in quantum physics. Okay, so he said, at that time, he said the particles has, light is like a particles has mass. Then come to Thomas Young. His very famous experiment called Young double slit experiment. Young's double Young's double slit experiment. Okay, so this is how we do like this experiment. We let the light pass through. We let the light pass through two slits. Slits means very small holes. Slits. Then it will form the pattern of dark fringe, bright fringe, dark fringe, bright fringe. Means it will have interference pattern. Means light is a wave. So he proved that light is a wave. He proved that light is a wave. But now, still unable to explain the radiation spectrum produced by a black body, means you let something absorb the light and then it emits out the light in different way. Okay, but never mind, we just remember. Newton said particles nature of light. Thomas Young said light is a wave. Then comes to John Dalton. I believe all of you know him from chemistry. Yes, John Dalton, he built up the Dalton atomic particles. Now we know particles can be classified as the basic one, atom. Come from John Dalton. John Dalton say, matter consists of basic particles that cannot be further divided, called atoms. Okay, so John Dalton determined the atomic model. So now we know, oh, there's very small particles called atom that we cannot see, but still unable to explain the light spectrum produced by atom. Okay, now come to J.J. Thomson. I believe all of you also know him from chemistry. Yeah, because of them, they can call as the father of chemistry, John Dalton and J.J. Thomson. So he discovered electron. Okay, he discovered, oh, the electron always move around the nucleus. Okay, so he discovered electron and he designed an experiment to study the behavior of electrons, but still unable to explain the light spectrum of the light by atom. Apa itu? He make an experiment, give lights to electron. That electron will jump to the next orbit. After that, when it jumps back, it will give up some light. And the light is hard to determine what color. Okay, so now classical physics finish here. Comes to our new generation called quantum physics. Okay, it comes to Max Planck. Okay, don't think Max Planck really looks like this. Actually, Max Planck quite handsome. You see, when they're young, very handsome. Okay, Max Planck. Max Planck. Planck, 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 Planck. OK，华语叫普朗克 Planck. Yes, he introduced the concept of quantum called discrete energy. Okay, in 1900. Yes, very good time. We also easy to remember. Okay, he find out that EM wave emitted by black body is in discrete form of the quantum energy. This energy in each quantum is directly proportional to the wave frequency. He shines a light on the metal, then this metal will give up the EM spectrum. The light spectrum. For example, he shines the light energy to the hydrogen. Hydrogen emits out light spectrum in this way. Okay. He gives the continuous light and the hydrogen give up the light in this way. So it's like a packet. Okay, it's like a packet. Okay, so discrete. Still remember what's the meaning of discrete? Anyone know? Discrete energy. Discrete means individual. So can you see the line is discrete, individual one by one. So we say one by one, individual separately. We call it as discrete. And this one, non-stop, we call it as continuous. Okay? Okay, so now comes to Einstein. He introduced the concept of photon after 5 years. Okay, photon not protons. Full. Full means the light energy. Photon energy is directly proportional to the frequency. That's why just now I tell you, you must remember UV has highest, violet light ray has highest frequency among the visible light. Okay, so here he comes to the theory. Einstein quantum theory of light was successful in explaining the characteristic of the photoelectric effect. Okay, that could not be explained by classical physics. Okay, now here is the quote of today. Quantum and photon. Okay, so in the school, I will test lah. Who didn't watch this, you die lah. So the quote of today, quantum and photons. In case I forget, I need to take picture. I always say, if you don't do, you die lah. Finally, no one died lah. Yeah, it's your hard work will help you in your future. Right, so now the okay, so now Max Planck introduced quantum discrete energy again. Not continuous, but discrete. The energy come out and emits out in discrete state. Okay, then Albert Einstein introduced photon concept. So apa itu photon? Photon propose photon concept using Planck's energy equation, which is E equals to hf. Okay, like Max Planck say, light energy is not emitted or absorbed continuously as wave, but it's emitted or absorbed in the form of line or discrete, one by one, they don't continuous. So in case of light, quantum energy is often called energy packet. So we don't say it has continuous energy, but we say it has the energy in packet. Apa itu? So so this is my cat's snake. So you can see, actually, inside here got many packs of food lah. So but different material will give you different combination. Okay, so this combination we said it's a packet. Okay, it's a packet. See my pen. Do you know this is a packet of food? So we call this is quantum energy. Okay, quantum. Remember that? Not remember, cannot eat. Okay, so we say it is a packet of energy. Okay, do you think she remember? She only can eat if she remember. Okay. She hungry. She don't remember. I'll check her. If she cannot remember, I cannot tell me packet of energy, then she cannot eat. So remember, quantum means a packet of energy. So energy is in packet, not continuous, but packet. Yichen says she only care about what's inside. Okay. Okay, so now understand packet. Okay, then comes to nail balls. Nail balls explain that the line spectrum by using hydrogen atoms. So it shines a light on hydrogen atoms, and hydrogen atoms absorb and emits out the light in this line spectrum. Not continuous, but one by one. So we say one packet of energy. So he said the electron in an atom orbits around its nucleus on certain shells only. So I believe all of you learn 288, right? Nucleus, 2 electron, 8 electron, 288. 8 electron, okay? 288. The orbits on certain shell only. But if you give it energy, it will go to the higher orbit. So we say the transition of electron from higher energy level shell to a lower energy shell emits out photon. So he said, let's say here, this electron goes to the next orbit. Okay, and then when it come back, you give like you lah, give you food, good rest, everything. The next day you can run very fast. But after you run, your energy gone, you become tired. So same as electron, electron will jump back. So when it jump back, it will give out the energy packet like this. Okay? Okay, so Neil Bohr say electrons will move within the shell, okay, if you give extra energy. Then finally comes to Louis de Broglie. Teacher, why so many chemistry people? As I told you, quantum physics is the world about inner part of the atom. That's why, yes, related to many chemistry scientists. Okay, is that right? Okay, so now he introduced the hypothesis on wave nature of particles in 1924. So actually, you can see they all like born around, they all knew each other. They are maybe some are friends, some enemy, I don't know. I think that's their life, their life works, So, De Broglie said what? De Broglie said the very important things. He said, actually he cooperated with Einstein. They all brought up the idea of wave particles duality of light and all subatomic particles. So here comes to the Newton's idea. Newton said light is a particles got mass. Then Einstein and De Broglie he is a French. His name is De Broglie. Also got people say broccoli, like De Broglie. De Broglie. I like to speak in De Broglie. Wait. So hi. I keep her in the cage. Look. 进去吧。Hi, Mr. Bean. Okay, okay, so they say, they comes to a conclusion, light could be a waves and could be a particles. Okay, so wave particles duality. Then but Einstein also say he don't like something very uncertainly. So he wants to know when will it become the wave and when will it become particles? What is the probability which you have learned in MS and maths? But until he passed away, still cannot sure. Okay, then how to know it's wave or it's particles? And comes to the cat. The cat. Cute leh. Okay, so comes to a person, he tells an imaginary experiment. His name is Schrodinger. Schrodinger. Our exam no the cat. Our exam no cat. Just tell you something I feel interesting about cat lah. And this is the phobia. Our exam no need SPM no Schrodinger cat. Okay, so Schrodinger say, Schrodinger explained this imaginary experiment means no cat is hurt or no cat is killed in this experiment. Okay, so he said keep the cat inside a box. Okay, then inside got one radioactive substance, and then this radioactive substance will give some dosage of radiation, which we'll learn in Form 5 to 6. And then here got the control. This control, controlling the hammer. If the dosage too much, so this hammer will drop down and hit the chemical. This chemical is poisonous and will kill the cat. Okay, so now, before you open the box, the cat could be alive or could be die. So these two probability exist on the same time. So here got the duality. Then means the light, when you not notice, it is in wave form and also it is in particles form. Yeah, the probability of both is 100%. Okay. Sorry. The probability before you open is 50-50. But you don't know when would you don't know when is it alive, when is it die, or when is it wave, when is it particles. Only when you open and see, then you know which state is it. Okay, so Schrodinger cat, dead or alive, to be or not to be. By the way, this is called cat eyes. We put it on the road lines Form 4, Chapter 6. Cat eye, total internal reflection. Cat eyes, cat eyes. Okay. I remember hearing that this is to show the problem of Copenhagen in interpretation of quantum mechanics. Yeah. Sure, danger cat. I feel funny lah, so I show you here. SPM don't test, never. Just tell you this. Okay, now is your must remember lah. Isaac Newton talk about particles nature of light. He said light is a particles. Thomas Young say light is a wave. John Dalton built up the atomic model. J.J. Thomson say got electron. Max Planck introduced quantum concept. Quantum physics means he said energy is in a discrete form and in a packet. Einstein said there is a photon energy, means energy from light. Photon means light energy. Now, what's the difference between light energy and photon energy? Normally, we say light energy is continuous, but photon energy is discrete, separated one by one in a packet. Okay, then Niels Bohr said the electron will go up and go back. When go back, it will emit out photon. Emits out the light in a spectrum, line spectrum, right? Then De Broglie say, actually Newton said, what Newton said correct, what Thomas Young said correct, because light actually is a wave particles duality. And also all the subatomic particles. So this is how they prove lah. They came out an experiment. Ta-da! Page 231. He said only wave can diffract. So he used the red laser light to make a diffraction. Do you remember I said diffraction? When the light passes through a hole, it will change the shape of separation. So he said light can give a diffraction pattern, and also light can give interference pattern. And he used electron. Also, the electron pass through a thin layer of graphite also give out the diffraction pattern. So he said all of the atom or subatomic particles like proton, electron, actually they are particles, but they also got light effect. If it is light, it also got particles effect. So it's called wave particles duality. Okay, so now come back to here. Niels Bohr say explain the production of line spectrum. What is line spectrum? This one. One line. What line spectrum? Okay, the transition of electron from the higher energy level to the lower energy shell will emit photon, light energy. Okay, so photon actually means light energy, a packet of light energy. So photon actually is a packet of light energy. Okay, a packet of energy. Photon is a packet of energy. So finally come to De Broglie. De Broglie said the idea of wave particles duality. wave particles duality, which is the matter and particles like electron have two characteristics. Means wave can act like particles, and particles can act like waves. Okay. So all about atom inside the atom. That's why if you learn physics in Form 4, Form 5, we also encourage you to learn chemistry. They related to each other. Okay, like comes to the quantum energy. So what is a quantum energy? Quantum energy is okay, so this is continuous spectrum, this is line spectrum. Quantum energy is discrete energy packet and not a continuous energy. Okay, packet. Discrete energy, one packet. Okay, is what? Is discrete energy packet. A discrete energy packet. Discrete means one by one separately, okay? And not a continuous energy. It is the what? So light energy is an energy packet known as photon. Photon are light energy transfer in quantum physics. The photon energy is directly proportional to the frequency. It is the energy packet. It is the energy packet. You delete this that can be emitted or absorbed. Okay. It is a discrete energy packet. Hi Joshua. I see you. You want this, Charles? I know you're very shy. But if you can open your camera, also very good. Okay, so now what is photon? Photon are light energy known as energy packet. Okay, energy packet. One packet. Okay. Okay, so now comes to the formula. Formula is, we say E directly proportional to F. Frequency. E is photon energy, means energy packet. Directly proportional to the frequency of the light wave. So as we learned in Form 5, Chapter 1, Math, X directly proportional to X. X directly proportional to Y. So when we want to change to equal sign, we need to give a constant. Okay, then the constant here called H. Yes. So it's like pi lah. So for example, they study the circle. The scientists study the circle. Outside here called circumference. Circumference. It says circumference is directly proportional to the diameter of the radius. The diameter of the circle. Okay, so we say circumference directly proportional to the diameter. So what's the ratio? So we say C directly proportional to KD. And we name this constant as pi. So what is a constant? It's a fixed number and everyone know it. So actually pi, most of the time we use 22/7 to represent it. So it's the ratio or the proportion to fixed circle and diameter. So same thing as here. How much energy, how much photon? If I just say photon, actually I'm saying it's photon energy in the packet. Okay? When I say photon, so in your mind, you must continue it with photon energy in a discrete energy packet. So that's science. We summarize everything short, compress it into a word. And you need to unzip it in your mind. So when I say photon, only I'm saying it's energy packet. Okay, so the photon is directly proportional to the light frequency. How much is an H? Right, so E is a photon. So when I say photon, only continue with energy. Photon is an energy. So H is what? H called Planck constant. Planck, all right? Planck constant. Who is Planck? Max Planck. Because of him, he introduced quantum. He also count the constant. And what is F? Is the frequency of light waves. Okay, and what is Planck constant? It's in your formula, don't worry. There, where is it? There. So we look at the, see, G is given, under quantum physics, G is given gravitational acceleration. This G is the universal law, the constant of Newton's universal law. H is the Planck constant. So 6.63 times 10 powers of negative 34 joule second. Okay, so it's how much? 6.63. 6.63 times 10 powers of negative 34 joule second. Okay, so if I forgot, doesn't matter, formula given. If I don't give, doesn't matter, formula given. Okay, then the properties of wave particles duality. This one you do it as your homework lah. Talking about wave particles duality. Then look at number 3. De Broglie proposed that particles with momentum p will have wavelength lambda. So here comes to the formula. Okay, so now he said lambda equals to h over p. So he say p is momentum of particles. What is momentum? mv means something The particles got mass and it's moving means it is momentum. H is what? H is Planck constant. What is it? 6.34. 6.63. 6.63 times 10 powers of negative 34 joules second. Lambda is wavelength of the particles. So actually, this de Broglie talk about wave particles duality. So you can see that the particles could have wavelength. The particles would have mass and wavelength on the same time. Okay, then okay, so now we can say we can see this one, lambda equals to h over p. And then in form 4, we learn momentum p is mv. So we substitute back here. So we can get lambda equals to h over mv. Lambda equals to h over mv. So we say it's de Broglie wavelength. So when we say de Broglie wavelength, means we're counting about the mass and the wavelength together. Now this is a formula. Okay, so it's number 3 and number 4. Number 1 is just now E equals to HF. So these two are called de Broglie wavelength. De Broglie wavelength. So this is the quantum energy, photon energy, E equals to HF. So this one come from where? F equals to C over lambda. Actually come from the wave. Here, V equals to F lambda. Okay, so that's why, like chapter, you need to remember RM, I love you, Roy gave birth. So the last topic, you also need to remember. So actually it's V equals to F lambda. So we say F equals to V over lambda. So we finally get F equals to V over lambda. And don't forget, in quantum physics, we talk about EM wave. So all of the EM wave have same speed, light speed. Where can you get it? Here. Nuclear physics, number 3. Light speed is 3 times 10 powers of 8 meters per second. Now all of them, all of the RM, I love you, Roy give birth, all have same speed. So we say F equals to C over lambda. Okay, or you want to change back as C equals to F lambda also okay. That's why, see, E equals to HF, we can substitute. E equals to HF, we can substitute F equals to C over lambda as E equals to HC over lambda. We substitute F equals to C over lambda. Actually, 1 and 5, you can always choose the better one. 1 give you frequency. 5 give you lambda. So if they If they give you F, you can directly use F, HF. If they give wavelength, you can use number 5, HC over lambda. They are the same, just they modify. Number 1 got frequency, number 5 got wavelength, right? Okay, so now let's look at calculations. Okay, photon energy and photon power. This one we leave it first. We need to look at the contour, like very easy. What is the wavelength of a photon if its energy is this? So please write info, alright? During this exam, I find out many people don't write info. So they say, what is wavelength of the photon? Wavelength question mark. Yeah, they don't give some information about wavelength. You also need to write here. Why then? Because at least you got a symbol, you know this symbol is in the formula. Then if energy, so actually E here is photon energy, 3 times 10 powers of negative 12 joule. So what formula do you have about photon and wavelength? Which formula is suitable? 1, 2, 3, 4, 5. Thank you, Bethany. The rest. Thank you, Rachel. Thank you, Jordan. Thank you, Grace. Thank you, Ethan. Okay, so yes, thank you. So actually, you can use E equals to HF first, but you find out don't have F, but we got lambda. So you can use, since F equals to C over lambda, you substitute HC over lambda. Means you can directly use number 5, HC over lambda. See, they purposely make it far. They purposely make it far. So 1, 5, okay, either 1 or 5. So now we can substitute. So IFS info, then choose your formula. Then we substitute. So E equals to 3 times 10 powers of negative 12 equals to H is 6.63 times 10 powers of negative 4 H. C is, I have no space here, 3 times 10 powers of 8 divided by lambda. So lambda equals to 1 up, 1 down. Can you count now? Count now. I'll get 6.63 times 10 powers of negative 14. Thank you, Bethany. Can I get marks here? Thank you, 7. Thank you, Stella. Yeah, it's in meter. Must have unit, okay? Okay, if your answer give you 2 decimal places, okay lah. But if your answer give you more than 4 decimal places, you can make it as 3 or 4 decimal places lah. Alright, so now next. Okay, this is the one I asked you to hold on just now. Actually, it's here power and energy. We learn power equals the energy over time. Okay. So now we say that photon energy is E equals to hf. So photon move in a vacuum with the speed c, light speed. To derive the formula of photon energy in terms of speed and wavelength. So we will get E equals to hc over lambda. And then if we say if n is the numbers of photon emitted per second, state the power of the photon p. Our answer is this. Actually, number 6 is p. I don't know why they put small p. They should put capital P, power, NHF. So use P equals to NHF. Apa ini? So we learn power equals to energy over time since form 2. Power equals to energy over time, right? So if n is the number of photon emitted per second, means n is energy of, n is numbers of photon emitted per second. You can see that actually this is P. Okay, so we will get P equals to N, and then times the energy is HF. Okay, this is power equals to NHF. So when they ask about power, and then how many photons, when I say how many photons or what's the power, we use this formula. So let's write the unit for first. Okay, 1.0 MW equals to wavelength 540 nm. Calculate how many photons generated by the laser per second. Anyone can tell me what is this MW? Small m, capital W. Power, mega power. Okay, it's okay. Physics and physics. Actually, I think Form 4, they should tell one more time. Last time Form 4, we will learn this. We should learn this in Form 4 again. So let's see. Small m actually is milli. Capital M only mega. Okay. Small k. Mega is 1 million. Kilo is 1,000.
So we are professor, but are you using your phone?
Huh? What?
I need to borrow it.
Okay, so and then n actually means nano, means times 10 powers of negative 9. Means you got 9 decimal places. This is 3 decimal places. Or we use index easier. Milliwatt, yes, very good. Oh, now I find out one thing can help you out. So actually this is P power, this is lambda. So please change to 1 times 10 powers of negative 3 watts. This is 540. Nano means times 10 powers of negative 9 watts. I find out what you can use calculator. Okay, if you have this kind of calculator, I can see the prefix actually is here. It's yellow color. So this is mega, giga, tera, micro, milli, kilo, fico, pico, nano. Okay. How to differentiate mega and milli? Capital letter and small letter. MM and MM. MM means 1 million meter. MM means 0.00000, 001 meter. So sometimes I saw the road side, the signboard, for example, Ipoh 288 km. Actually, the person who made this notice board sure not the science students. So if science students, you should use small k, small n. So every symbol, every letter in science or physics, capital letter or small letter got its own meaning. So if you write wrongly in exam, also consider wrong. Okay, then this one, this calculator. Okay, how to press this? I just learned. Okay, if you want to get the prefix, you for example 1 megawatt, right? Sorry, 1 milliwatt. So it'll be you press 1 first, then you press option, then you press once you press option, you press 3. 3 is engineer symbol. Then you'll find out got many lah, got the kilo, got the milli, got the mega lah. Then you press lah. I think kilo is number 6. I'm not sure. Press option, press 3. Get it? So you have 2 ways. 1, memorize them. 2, memorize how to use calculator. That's it. Okay, so now, how many photons are generated? Since power is given, we use this formula, number 6. So actually, this is power of number of photon used. So P equals to NHF. P is 1 times 10 powers of negative 3 equals to N, don't know. The second is M, not W. Oh yeah, correct. Yeah, right. So it's nanometer. Thank you very much. Okay, so actually you need to be more sensitive lah. You need to be more sensitive. The yellow one called unit. In front of unit, we call them as prefix. Engineering prefix. So why do we have prefix? See, times 10 powers of negative 3, 1, 2, 3, 4, 5, 6, 1. You need to write 6 times then, but this one you just need to write 1, 2, 3. M. Okay, so size is like that. Like you must be able to easily compress things and also easy to unzip unzip the things. So we make it in one symbol. You need to be translated. So H is given in formula 6.63. 6.63 times 10 powers of negative 34. Frequency give or not? Frequency not given. What's wrong? How? No frequency. But we got lambda. How? What's the relationship between frequency and lambda? Anyone? Hey, then yeah. So actually, we can use the formula from here, number 2. F equals to C over lambda. F equals to C over lambda. So actually, we can, before we substitute, we also can do this NHC over lambda. So this is not given up. So we also can say P equals to NHC over lambda. So you substitute, actually you just need to substitute yourself. You substitute number 2. This is not given. Like E equals to HF can be substituted as E equals to HC over lambda. So do you jot down in your in your formula list already? Okay, so we can 1 times 10 raised to negative 3 equals to N 6.63 times 10 powers of negative 34 and 3 times 10 powers of 8 divided by lambda. Lambda is 540 times 10 powers of negative 9. So N equals 2. You can show you move or you just do it in your calculator also can. If you want to show you move, you move like this. Cross multiply up, then divide. Anyone still not sure how to move them, please come to see me. When you're free, I'll teach you how. So if you want to skip this step, also can. Answer. Do I need unit? I no need unit because how many photons means number of photons, no need unit. Always look at the left hand side, no need unit. So this one correct. So if you add any unit here, let's say, then directly wrong, understand? So this is number, so no need unit. If you just have 2 decimal places, sorry, directly wrong. So at least 3. So when I mark, I still find out many students write 2 decimal places only. Okay. So now tugasan 1, So your homework today, tugasan 1, 201 until 202 lah. Please do it now first. See we can discuss how many. I need to wash my face. My cat's fur making it feel very not comfortable. I'll come back within 3 minutes, okay? Bye. Okay, any question to ask? So always involve formula first. Actually, this is lambda lah. So this chapter, one of the tricky thing is the prefix and the way they write without prefix. So actually, 10 powers of negative 10 means 1 times 10 powers of negative 10. Okay, so you can translate in this way lah. 10 powers of negative 10 means 1 times 10 powers of negative 10. The mean velocity of the electron given the mass of the electron is this. So choose the formula, and according to De Broglie, means we can use lambda Vm. Which formula we can use? Obviously, this one, De Broglie wavelength. Lambda equals to h over mv. So do not worry too much. I won't ask too many things. As long as you write info, you can get your formula. Lambda equals to h over mv. So lambda 1 times 10 powers of 10, negative 10, 6.63 times 10 powers of negative 34. 9 times 9.1. 9.1 times 10 powers of negative 3 times v. So what do you want? You want v. So v cross multiply up, lambda bring down. So we'll get, or you can directly use v equals to, from here you directly modify your formula. V equals to h over m lambda. So you got two ways lah. One way is you substitute and only you move. When I was young, I feel this method is very hard for me. Okay, I like to subs first, then only I move. So depends on you, which way also can. So V equals to. So one way, directly substitute. Second way, you modify the formula first, then only you substitute. Answer is 7285714.286 meter per second. Can you write 7.7.28 times 10 powers of 6? Theoretically, yes, but no. Because we want the original decimal, 3 original decimal. And I encourage you to write your number in, starts from the back, 3, so same as here lah. From my calculator, you can see comma, comma. So 3 digit space up, then 285 space up, 7. Okay. Last time we used comma, but the comma sometimes while writing, it might be misunderstood by one. Some people lah. So we use comma last time. But comma is quite confusing. So now I encourage you to do this. 3 digit space up, 3 digit space up. And we want original 3 decimal places. So do not change to standard form. Why like that? Because you will find out when you apply this in sine cos tangent or what, when you want to continue using this number for the next formula, the difference of 3 decimal places and 2 decimal places will make a very big difference. Okay, so we want original decimal 3 decimal places. Okay, so this one wrong, this one okay. Original 3 decimal places. Very good question. Alright, so now calculate the energy and wavelength of light photon with frequency of this. Okay, so frequency is 4.72 times 10 powers of 14 hertz. Energy equals to don't know, wavelength don't know. So first we can use E equals to whatever. And we choose from formula. E equals to whatever. Channel number 1. E equals to HF. So E equals to Planck constant times frequency. Then we will get how much is it? Anyone, when you press calculator, you cannot get it. Maybe the way you press calculator wrongly. So please come to see me. What's the unit, huh? Yeah, Joule. Capital J, small j also wrong. So you must be very sensitive to the unit, capital or small letter. So we can get E equals to HC over lambda. See, number 1 and number 5. HC over lambda. Okay, substitute first, or you can directly modify. When I was young, I like substitute first, but now I like modify first. Then I substitute. I'll get lambda equals to 6.3559 times 10 raised to -7 meters. Okay, calculate the frequency and energy of a blue light with wavelength 516 nanometer. So wavelength is 516 nanometer. Anyone can change back to meter. Yes, thank you. Nano. Nano is times 10 powers of -9. Yeah, thank you, Savendra. So we say frequency and energy. So E equals to how much? F equals to how much? So you want to count F first? Can you want to count E first? Also can. So F equals to C over lambda. It's in formula number 2. So F and lambda inversely proportional. F equals to C over lambda. Come from the formula in last field. The V will change to C. Speed light. So 3 times 10 minus 8 divided by 560 times 10 minus 8. 5.3571 times 10 minus 14 hertz. Then they want E. E equals to HF. Or E equals to HC over lambda also can. Okay, everyone, pay attention here a while. Just now you asked, can you just make your answer like this? Say original. Okay, see, this one, I use E equals to HF. This F is 2 decimal places only. This F is 4 decimal places. And you can see the first 2 decimals still the same, but that's the third one already different. So, if you leave your final answer in 2 decimal places only, it will make a huge difference for the next solution. Okay, so please give at least 3, but I like 4 because trigonometry, sine, cos, tangent, normally we take 4 decimal places. What is the unit for number of photon? No unit. Number of photon, no unit. Like number of electron, also no unit. Okay, so N is like 1 mole of atom. Do we have unit? The 1 mole is, I forgot the number, a number of it. 1 mole of atom means how many atoms? N is like 1 dozen of pence. So we got 12 pence, not unit. Pence is not a unit. Okay, so be careful about this. That's why we must have at least 3 decimal places. 4 is the best now. Okay, if not, it's a huge difference. Not huge difference, not so accurate. So if you want to launch a rocket to the space, or you want to explode, makes a nuclear bomb explode, the decimal place, actually they will count up to 10. Yeah, so if you left so less of decimal places, it will make accident will happen in any time. Okay, so your homework like that. Okay, so I think next week we can finish chapter 7 and get into chapter 6. Next week we are going to learn photoelectric effect. First we learn theory, not hard, and then we are going to calculate it by using the combined formula. So actually we are going to learn number 7 and 8. They look like very difficult, but actually they make it difficult. Quite easy lah. Okay, quite easy to understand. Then normally exam, most of the time exam asks about photoelectric effect lah. Okay, next week we can finish this and may get in chapter 6 a bit. Okay. What formula, for question 3, what formula should I use? Question 3, what formula should I use? Question 3. How many photons n equals to question mark wavelength lambda 465 nanometer needed to produce E equals to 2 times 10 powers of 3 joules? What do you think? Can use E equals to hc over lambda. Then I thought P was the number of photons. Oh, P is momentum. Sorry. How many photons? Number of photons emitted per second is in P lambda. Maybe we treat this as P equals to E over T. So we treat this as power 2 times 10 powers of 3 per 1 second. So now this is 2 times 10 powers of 3 watts. So we can use P equals to NHC over lambda. NHC over lambda. We can, since they give lambda, we use HC over lambda. And this is the N. Okay. Any other question? Hello? Mình sẽ chiếc này. Okay. Okay, so now this one, wavelength 1.0 pm. Careful. P is pico times 10 powers of negative 12. Alright, times 10 powers of negative 12. Yeah, the T is 1 second. We make it like this. So P is 1 times 10 powers of negative 12 meters. Right? So this is n photon, number of photon. Okay, still got any other question? If no question, we can stop here. Okay, thank you everyone. Bye-bye. Thank you everyone. See you tomorrow. Bye-bye. Thank you. Bye-bye. Thank you. Bye-bye. Thank you. Thank you. Bye. Thank you. Bye-bye.